Finding maximum and minimum for trig, they usually use the same types of tricks, and that is understanding that for sine, cosine, the maximum and minimum values that those functions get to are positive and negative 1, unless there's some kind of amplitude change at the front. But if we're just looking at sine or cosine, remember that sine's got that kind of shape. It goes up to 1 and up to negative 1. So for sine of x, our maximum value is 1, and our minimum value is negative 1. So usually for these questions, try using either the positive or the negative one for the trig that you're looking at to try and find maximums and minimums. You should probably also consider 0 as well, because sometimes, given it depends on the type of question, but 0 may actually give you a minimum too. So let's have a look at the first question here. It says, find the maximum and minimum values of the following expressions. And so let's write out the first one. We've got sine squared 2x plus 2 sine of 2x plus 2. Now I'm just going to rewrite that a little bit differently so you can see clearly. You've got sine of 2x all squared, and then 2 sine 2x, and then 2. Now thinking about what we just talked about, maximums and minimums, the biggest thing that this can be, this is sine, and it doesn't matter that it's 2x, all that does is it changes the period of the function. Okay, so for us, and that just means you have twice as many in between 0 and 2 pi. So for us it doesn't change the maximum minimum. The maximum is still going to be 1. Okay, for that. Our minimum would still be negative 1. So let's try and find for our maximum, for the whole expression that we've got here, let's try and use that understanding or that knowledge that we have that the maximum that this can be is 1. Let's put that in. So the biggest thing that this can be is 1 squared, plus 2 times the biggest thing that this can be, which is 1. There's nothing bigger that this can be, plus 2. And this expression gives you 1 plus 2, which is 3, plus 2, which is 5. So what we find is for this expression, our maximum value is going to be 5. And similarly, let's try for our minimum. Now it's worth doing two things here. It's worth trying the negative 1 and also the 0, just because when you're squaring, remember that if you square a negative number, it can become positive. So let's try x, or I should say, let's try saying that our minimum for sine of 2x is negative 1. So I'm going to put that in. So let's have negative 1 squared plus 2 times, and sine of 2x is negative 1 plus 2, which gives us this squared is positive 1 minus 2 plus 2, which gives us 1. Okay, I'm going to try also using sine of 2x. We're just going to say is 0 just to test that out, to see whether we get anything smaller. 0 squared plus 2 times sine of 2x, which I'm saying is 0, plus 2. Well, that gives us 2, and that's bigger. So that means what we've found is our minimum is going to be 1. So to finish it off, write down your expression again, just so you can show what you've done. So you've looked at an expression that had some trig inside it, and you've found the minimum value, which is 1, and the maximum value, which is 5. So that's the most and least that this function can be. In the next video too, I'll show you quickly what this looks like on the TI and Spire, so you can actually see that these make sense for a minimum and maximum. Alright, for the next part of this question, we're going to look at now the reciprocal. Okay, so 1 over the expression that you were looking at in part A. So I'll just delete this section here, and we're going to use the same kind of ideas again for B. So we know that this expression under here has its maximum at 5 and its minimum at 1. Now if you have 1 over a function, if you're trying to minimize this to make this as small as it can be, you want to try and make the bottom line as big as it can be. Okay, so again, if I had something like that, the minimum will be when A, whatever A is at its biggest or at its maximum. And that's because you're dividing 1 by the biggest possible thing that you can. That's making this as small as you can. In the same way, the maximum will be when A is the smallest that it can be. So when A is the minimum. because what you're doing then is you're taking the smallest thing a can possibly be and dividing 1 by that. So if you're dividing 1 by the smallest thing you can, you're trying to keep this as big as you can. You're trying to keep that numerator as big as you can. So we know already the maximum and minimums for that expression on the bottom. So what that means is we can straight up write this down for 1 over sine squared 2x plus 2 sine 2x plus 2. We know that our minimum will be when a is at its maximum. So the maximum here was 5, so that's 1 over 5. That will be the smallest thing we can get here. Okay, and our maximum is going to be when we take the numerator 1 and we divide by the smallest thing that this could possibly be. And we know the smallest thing that can be is 1. So that's 1. So for our two functions here, the minimum and maximum, 1 and 5 for the first function. And because this is a reciprocal, we're dividing by the maximum and the minimum to get the minimum and maximum for the reciprocal function. So the key thing here with this one, understanding that for trig, sine and cosine, the biggest values they can be is -1 and 1.